Thank you very much, and thank you all for joining. I am calling from Huntington, West Virginia, as it was just mentioned. You can see a few of our buildings over here at our relatively small medical school, the Joan C. Edwards School of Medicine at Marshall University. And I would like to talk to you about predicting future outcomes of national exams. As mentioned, I am the Associate Dean for Medical Education and an associate professor in one of the departments over here. This is a deceptively very short outline, but this will be a full presentation, so please bear with me. But during the course of this next 45 minutes to an hour, I'd like to identify the problem being these high-stakes national exams. I'd like to identify some solutions in assisting our students with feeling that they may be prepared for these exams, and helping to identify those that we feel with the data at hand may struggle with these exams. I'd like to turn to a little bit about the data analysis that we and others use for this kind of work. And I want to hesitate or I want to warn you, I am not a statistician. I'm not a math person. I am going to be talking about math and statistics. Bear with me. If you don't get it or understand what I'm talking about right away, it took me many, many times of thinking about this over and over again to understand some of the issues associated with the data analysis. So I will go through some of that, but please review the slides later and look at it a little bit carefully, and go online to read up a little bit about some of the things I'll be talking about if they don't make sense to you right away. So don't worry about it in terms of the data analysis. But what I really hope that you will get an idea about is I will show you some of our data. But more importantly, I want to address the process that we're using with this predictive data. And that's what I think will be the take-home message and part of the presentation that you will value the most, I hope. We'll finish up with some final thoughts and some questions. So let's first talk about the problem. Our school, of course, being a medical school in the modern times, has a huge requirement that's placed on licensing exams. We're really, our and all medical schools in the country are required to have our students take step 1, 2, and 3 exams, and these are very high stakes exams. Our students get very nervous about them. They think that almost about these exams. Other programs like nursing programs and pharmacy programs, and perhaps some of you in the audience who are aware of other ones that I'm not aware of, also exist, these national licensing exams, and they're becoming more important and used more and more. So one of the issues of the problem, and I'm not going to address much about this now, we could spend a full hour on this, is do we teach to the test? So as you see, I've got there, teach to the test, should we? Well, as the Associate Dean for Medical Education, I would say absolutely no, we do not. That's not what we're about, teaching to the test. However, we all understand, I think those of you in the audience know, that our students are thinking about this exam, and our assessment questions and our assessment overall should probably be geared to helping students on these exams when they do come up. So although we don't teach to the test, we do think about the test very often, and our students always tell us, please examine us on things that will be on step 1 and nothing else. And we have to, of course, think about that, but be aware of it, even if we don't necessarily do that. Students are unidirectional in approach to these exams. They are thinking about them right since they start. They talk to their classmates about them. They get all excited about these exams, and it takes over their lives, as I mentioned. It's also made worse that our program, and a lot of programs, actually require them as well. Not only are they required for licensure and to be able to practice, but we actually require our students to take them and do and do well on them before they can move on to their next year, for example. And I'll talk to you about that in a moment. But this all amplifies this issue that these exams are extremely important. So knowing that that's the case, what do? Well, we can identify students that are at risk. We certainly can identify any students, even those that are not at risk, but the ones that we're worried about, of course, the ones that we can identify ahead of time that may not do well on these exams. But before we do that, we need to ask ourselves, what indicators are we going to use, or what predicting variables are we going to use? I'm going to show you, we've used quite a bit. I'm going to talk to you about thinking about the thinking that goes behind selecting some of these variables. You also want to think about how and when to intervene. So if you are going to be identifying students who are at risk at not performing well on a very large standardized exam that they're going to take in the future, you want to ask yourself, when do you want to start discussing the data with them? When do you want to start looking at these predictions, and how early or how late do you want to intervene, if you do decide to intervene at all? And then also, even if you have figured that out, you know when you're going to intervene, you know what predictors you're going to be using, you also need to ask yourself, what can you offer your students? What remediation will be available? What kind of delays are they going to be able to do? What's the program in place that, let's say you do identify 4 or 5 students who are predicted to do poorly. So there's a lot of things to think about, but I think it's in the best interest of the student to think this way. And then finally, one of the problems that exists today is that many of us do not use data-driven approaches in our predicting, if you will, of how students will do. We frequently use anecdotal evidence. The dean of students has heard a particular student come across his or her office, or maybe the academic affairs person has said this person has had some professionalism violations, et cetera, et cetera. But, you know, our dean came to us and he said, I want data. I want you guys, I want to be able to see data in my hand and not get as much anecdotal information when these students are brought to my attention. And he actually tasked us with the program that I'm discussing now. So let's talk about the solution. That's the problem. What can we do? Well, we have a lot of data. We have a lot of descriptive stats. ExamSoft has made our life really, really easy when it comes to analyzing the exams themselves, such as KR20 values, et cetera, et cetera. We can actually look at the questions themselves and come up with point by serials and all sorts of question analytics, and we can look to see if, you know, all sorts of information around what the student has had before he or she even applied to medical school, how they're doing while they're in medical school, et cetera. So we do have a lot of data, but when it comes time to coming up with prediction algorithms, for example, using chi-squared analysis, linear regression, ANOVA, students' t-tests, etc., we're going to need to figure out this data, organize this data, and use this data effectively. Now, we actually do have a rich source of potential data. So those of you who are thinking of coming up with predictive algorithms or a process for predicting students who will do poorly on exams, you actually have a huge amount of data. Now, how accessible it is for you, who's going to manage it for you, these are all things that have to be worked out. But if you think about it, we have hundreds. I know on our end, we have dozens and dozens of internal exams. Our students are examined all the time, much to their disappointment, but it also helps prepare them, of course, for these national exams. We also have a lot of pre-admissions data, for example. Before a student ever comes in and sets foot in the university, they're going to come with the MCATs, different parts of MCAT scores, their backgrounds, you know, their gender, what schools they come from, et cetera, et cetera. We also have a lot of, in our case, we have a number of different external exams. So the NBME, the National Board of Medical Educators, actually sets, we work with them to design some exams that we give to our students. So we give them in-house, but they're actually external exams, and we have those that we can use. Attendance is also something we don't use, but attendance is something that people are interested in and can be a variable in the data, who comes and who doesn't come to courses. And then there's a whole bunch of different behavioral data that you might have. For example, students who are brought up to disciplinary hearings or who have professionalism violations, etc. We haven't done that. That's something in the future that we might start doing. But you can use data, behavioral data in predictions if you have access to it. The data is not enough, as I mentioned here at the very end. What are you going to do with it? And that's what I'm going to spend a fair amount of time talking about as well. Let's think of some more issues, though, before we start. And I do want to show you data, but before I do so, I want to explain what the data means, because I think it won't do the justice just to show you our raw data. So let's start with the issue of what data you have access to. So you probably have access to many, many, many years of exam data. You have access to probably many years worth of pre-admissions data. Now, it may not be available in your office. You may want to find out how to get it, but you want to have access to a lot of data. And before you start making predictions, you're going to have to actually put together a training set. So in our case, it was 5 years worth of exam data or pre-matriculation data that we used to develop the algorithms that gave us formulas that then we can plug our current students into. So the training set was the 5 years worth of data that I'm going to be talking about that developed the formulas in the first place, our predictive algorithms were based on, and then the actual data, the predictions of student X, Y, and Z that are coming through the courses now are the ones that we're applying to this training set. So I hope that makes sense, but do think very carefully about all the historical data that you're going to be able to use, whether it's 5, 10, 15, or 20 years worth of data, and how easy is it going to be for you to access it, and what databases you might have, etc. Again, ExamSoft is making this easy for us now, but we're only newer. We only started implementing ExamSoft recently, so we had other databases that we had to rely on for some of this historical data. Now, how far back can you go with your data? The larger the data sets, the stronger the outcomes, and that's one of the main important things, especially with some of the multiple linear regression I'm going to talk to you about. You really need to have a robust data set with large N's, if you will, hundreds and hundreds of students, if you want to do the statistics appropriately. Now, you also need to think about what your students worry about most. And in our case, it's step 1 and step 2 is the biggest worry for us. So that's our outcome. But in your case, it might be other things. And then the other thing you might want to think about is, what do your administrators worry about most? Well, we worry about students doing well and not having to spend the money, hundreds of thousands of dollars just turning their wheels and having to repeat and repeat and repeat. So I think the administrators worry about the same things students do, but they worry about other things that many students don't think about sometimes. You also want to think about who gets the data, and I'm going to show you that we have these academic dashboards, and they're only accessible to the senior administration. And we don't give the data that I'm going to show you to our students right away, because it can actually get them a little bit anxious. So we have to know our student first before we decide whether or not the data will be helpful for them directly or not. So who gets the data is very important. And then the other thing I want to finish up with issues to ponder about before starting on a predictive algorithm process is, what timing is the data relevant for you? So for us, we've implemented a continuous process where once we've set up the formulas and the linear regression models, we actually, every single time an exam has occurred, we auto-update, if you will, our predictive capabilities for our students. However, for some of you, you might not want to do that. You might want to do it at the end of the semester, at one point at the end of the year, first year, the second year, for example. It all depends on your program and the exams that you're going to be predicting for, or what you're interested in. But you do have to think about all these things. Okay, let me talk to you a little bit about our program so you can understand why we did what we did in the next set of slides that I'll show you. We're a relatively small program in West Virginia. We have about 70 to 80 students per class, so we can give quite a bit of personalized attention. But our mission is to train West Virginians to practice in the state. So we get mostly West Virginians, or at least that's what our aim is and our goal is for the admissions process. We have a strong program in rural medicine, and we really do encourage family practice and community medicine, etc. We have completed our curriculum integration last year, and some of the data I'm going to talk to you about doesn't directly affect, I'm not going to talk about it directly, but you can use predictive algorithms and such to sort of test how your newly integrated curriculum is working, etc. We're going to be doing that in the near future. If you're interested in curriculum integration, we have published in the International Association for Medical Science Educators. Just look under my name and you'll be able to find that. But anyway, we've moved to ExamSoft, as I mentioned recently, and I'm sorry, Stephanie, I should put the capital E and a capital S there with a little R afterwards. It's probably registered. Last year, and now we do all of our exams on ExamSoft, at least for the first 2 preclinical curriculum, and we're moving to our third and fourth year clinical curriculum, also assessments to be moved on ExamSoft. Now, So that makes it a little easier for our, to get our data, but again, it's still new for us. And here's very important, we're going to be looking at step 1 and step 2. We require, like most schools, but not all, for the step 1 to be completed by the end of the second year. So that's when students get most anxious, at the end of the second year. We require the students to take step 2 by the end of the third year. Now, we require passing of step 1 before students can move on to clerkships in the year 3. So the passing threshold is set at 192 by the NBME, and they must meet that before they can go. Now, one caveat to that is the last thing I've written here is we only allow students to miss out on a max of 2 rotations before they must repeat the year. So what you can see automatically is that if we're going to be doing predictive algorithms, we have a number of opportunities. Students miss nothing, and they're predicted to do very well, so they'll take the exam on time. Students miss out on 1 rotation, perhaps, because they're predicted to do around the passing score. Student might miss out on 2 rotations because they're really predicted to do poorly, or they might even be predicted to do so poorly that they may be asked to repeat the year. So, you know, you have to have things in place set up before you want to share some of this data with them. Okay. Now, what's the importance of the prediction data? I can go through this quickly, is we need to identify struggling students so that we can intervene and assist them. And we have various programs here, like help programs or student peer programs. We have a woman who's just dedicated to helping struggling students, if you will, with the resources. We can help them set realistic expectations early. So some people have unrealistic expectations in the medical field for wanting to do, for example, dermatology, and their grades simply do not support this. Well, if we have the data for that, tell them this is how you're predicted to do on step 1, and this is way, for example, different than your expectations for your residency, then they may, you know, may be tough news, but they may need to hear that. We can offer them options, I just mentioned that, to extend or delay, so that we can be fair to everyone as possible, try to do the best thing for the student with data at hand, and so that our dean does not meet with them with no data in hand. And I mentioned that earlier. He wants to see data if a struggling student comes to his office so that he can talk to them with more informed decision making. And then when we do meet with them, with the students, we can be informed as possible, as mentioned. Now, we also want to do predictive sort of data analysis because we have an ongoing measure of our effectiveness. And the LCME, which is our accrediting body, is asking us more and more, all of us, to show how our ongoing review process is going. And this can be part of it. So how well are we doing this year as compared to last? Are we having less people fail their first attempt at the step 1 exam, et cetera, et cetera. Okay? So who has done this? A fair amount is written for the admissions point of view. If you look in the literature and you look at predictive capabilities, you'll see admissions committees, either for what have we gotten right in our admissions, or what have we used in the pre-admissions material that actually conforms well or predicts well for good doctors to practice in the field. All sorts of questions related to that. And you can imagine the data is quite messy and the field is all over the place on admissions, and the importance of the pre-admissions process in predicting future either exams or performance in residencies, etc. A number of blogs and publications are written from a student's point of view. You will see a lot of information, for example, on California schools talking about using predictive algorithms for what MCAT you're going to need before you apply to this school and this school in California. That kind of thing. Students are really anxious about that. A number of publications come from educators like myself at medical schools. And then what you'll find is a whole lot of publications come from residency programs saying you're going to need this kind of step 1 or step 2 or this kind of performance to get into a pediatrics residency or a skin dermatology residency, etc. So there is quite a bit about it. Now let's move into the real nitty-gritty now about the data analysis portion. What data is it? What type of software or hardware or statistics, I should say, can you use for making predictions? Well, I've got 2 of them here. There are more. I've got the chi-squared, Pearson's chi-squared test for independence on the left and a linear regression. We've used both of these. You can also use analysis of variation, something called Well, you can use student t-tests and all sorts of things, but these two are used quite commonly. Let's start with chi-squared. And what chi-squared is it's a statistical test commonly used to compare observed data with the data we would expect to obtain according to a specific hypothesis. So how likely is it that an observed distribution is due to chance, or it's also known as the goodness of fit analysis. And it works very well with categorical data. So it works well when you're looking at a yes or no, or a pass or fail. It does not work, and you cannot use it if you're looking at percents, ratios, or like height in terms of inches, or exam scores from 0 to 100. It doesn't work. You really need to look at what's called categorical data. So that's a limitation of chi-squared test. It also tests something called the null hypothesis. And the null hypothesis states that there is no significant difference between the expected and observed results. So the chi-squared analysis is geared toward proving you wrong. You have a hypothesis, and that is that something relates to something else. And this test says, no, we're going to try to prove that that's not correct. So another limitation or problem for some people, and that's why we don't use it very much, is that you cannot get quantitative information on the relationship between two variables. So if you're going to ask, performance on step 1, and you're going to be looking at end of the year exams for year 1 and making a comparison, you can get a probability, but you're not going to be able to get quantitative information. And I'll show you what that looks like. You're not going to be able to actually get an actual value, or say this is 10 times as strong, or you can't. You can just get a probability. And I'll show you some of that in the next slide. Linear regression, on the other hand, is an approach of linking a set of dependent variables, which are known as y, to an independent one, x, or a number of independent ones. You can have many, many independent variables. So that would be how well students do on step exam. That would be your dependent variable, and all your independent variables would be all the pieces, all the variables that go into predicting that relationship. And it looks at a linear relationship, so it's the best fit through a regression line. I'll show you that in my next slide. It's a great way to come up with a formula. That's what I like about linear regression, is that you can, once you do all your work, you actually get a usable formula that you can then plug a student into. And I'll show you what that looks like. And that formula really is the slope of the line. And you can use it to predict a future value. It also allows one to come up with an adjusted R-squared value, or power of the regression provided. So again, if you're looking at step 1 performance and you have one particular predicting variable, you're looking at the end of the year exams in the first year of the medical school, and you can actually come up, and if it gives you an R-squared value of 0.2, that means 20% of the variance of step 1 can be explained by that exam. That's a very powerful number. And so it gives you that plus a formula, and I'll explain to you, it also gives you some coefficients that you can use in constructing the formula. However, there are a whole bunch of assumptions that you need to be met, and I don't want to get into those. I have them on a slide. I'm going to skip them, but you can go back. So you need to make sure that there's a number of assumptions. Your data has to fit a certain set of assumptions before you use this a tool, but it's a wonderful tool if they do fit those assumptions. Let's look at some examples. I have one on the left. It's a chi-squared example, and this is a hypothetical pass-fail exam study. For example, remember I said it had to be categorical variables. So here, our variables are being absent or present in class. You see that on the left. And on the top, you see step 1 failure and step 1 pass. So what you're asking is, do the group of students who do not come to class fail step 1 at a higher rate than those who do come to class? The chi-square analysis is going to really try hard to disprove that and say there is nothing. There's no association whatsoever between those two variables. Now, when you do these, the data can be done on an Excel sheet or a statistical package like R or etc. But when you come up with the data, and in this case using the data in this contingency table up above, the chi-squared or probability value is 3.418. However, that probability is associated with a p-value of 0.065, which does not conform to the p-value of greater than or equal to 0.05, and therefore This says, no, you do not reject the null hypothesis in this case. So the students who, doesn't matter whether they come to class or not, they still have the same chance of passing or failing due to random what have you. Okay, so students who come to class are no better than students who do not come to class. That is the beauty of a chi-squared test. Linear regression, on the other hand, allows you to provide you with a formula, as I mentioned, for future analysis and provides an adjusted R-square value, as I mentioned. So it actually gives you a line or a curve of the line, which is the y equals mx plus b, which is the slope of the line, and then you have an error value associated with that. So what happens is that, and I'll show you in a slide above, is that the m will be the slope, the x will be your variable, and the b will be your y-intercept. So if you notice in the data above, you have high school GPA, which occurs, of course, before the values of the university GPA on the y-axis. And so what you're asking is, here's a whole bunch of data on people's high school GPA. How does all that data do, well, to fit at predicting a university GPA? And then what you can get is a formula so that in the future, you get a student with a high school GPA, and you can plug it right in and come up with an exact value. So for linear regression, the y can be continuous, and your variables can be continuous. In other words, you can get a score of 2 for a GPA all the way up to 4. It's not like yes or no, which is what we needed in chi-squared. So it's very, very powerful in that regard. Okay, let me tell you a little bit more. This is where it gets a little hairy, but try not to be a little overwhelmed by this. And this is the formula for linear regression. What I showed you earlier was a linear regression formula for one variable. But what many of us like to do is multiple linear regression, and that's what this has shown. I have 2 variables up there underlined in green. Y, which would be the step 1 score, or the dependent variable, equals to, and we call that a continuous response variable, the step 1 result, is equal to B1 times X1. And B1 is the coefficient of value associated with the variable of, let's say, end of the year, first MS1 exam scores, plus B2, which is a coefficient associated with a different variable. In this case, it might be a comprehensive end-of-the-year exam. That's different than X1. So in this case, you've got 2 variables. Each variable is associated with their own sort of slope value and therefore their own what we call coefficient, plus the BO, which is the same as the y-intercept, so where it hits the y-axis, and then an error unit. So what my point is that you will have, and I will show you coefficients in our data that you can actually add, multiply to the variable that you're looking for. So x1 and x2 with 2 different variables, you can have a formula with the coefficients associated with them, and you can build this on. This is a stepwise linear regression. And the other thing I want to tell you is that the B1 and B2, 2 different variables that you're using to predict for step 1, they come with their own p-values. And they come, so it's the p, and they come with their own adjusted R-square value. So the adjusted R-square value can be really high. It can be 30%. But your p-value, if it's very weak, then you can't use it. And that's why some variables can and cannot be used. I'm going to show you tons of variables that we analyzed, but at the end of the day, only a few of them were actually robust enough to use. Okay, a little confusing, I know. Look at this again at your own time, and don't be too worried about, for those of you like me who are non-math people, about getting all of this the first time. I'm going to skip this chart, but this graph, but I'd like you to look at it at your own time. If you do decide to do this, these are the assumptions you need to make, and there are actually more before you actually undergo this this kind of test, if you will. And you may want to talk to a statistician to help you. There are programs like SPSS that will actually walk you through all of these and let you know whether your data is robust enough to use. Okay, or your variables will fit properly. Okay, so let's move on to the data and talk a little bit about the great debate to use pre-matriculation data or not. So as you know, for all of us in these professional schools, the students come to us with a whole bunch of pre-matriculation data, whether it's high school or university data. For us, it's university. And the question is that useful? Well, pre-matriculation data is very important for admissions committees, that's for sure. I'm getting people admitted, right? They're relying on that. However, is it useful for predicting success in national exams, career specialization, or other internal medical exams? The answer is, I don't know. And the reason is there are publications that are in favor of its use and publications that are against its use. In other words, against the use of variables which are associated with prematriculation to make assumptions on whether they correlate well or not with performance on an exam in medical school. Now, our approach is to set all of that aside and just let the data do the talking. So we used as many variables as possible, including prematriculation, and we used a stepwise linear approach. And we just did one at a time, then we added it to another one and added it to another one, and things would come in and drop out depending on their p-values and their adjusted R-squared values. And so we used prematriculation data, medical school data, and we also used, of course, our major outcome analysis was step 1 and step 2. Those were our dependent variables that we used exclusively. You might, of course, have other things that you'd like to use. Okay, let's look at some of the pre-admissions variables, and you'd be probably surprised at the number of things we looked at. So you know we have MCAT scores, but what you may not have realized is that you can break them down into verbal reasoning, the physical sciences, biological sciences portion of it, number of MCATs taken prior to medical school matriculation, so how many times you took the exam. All of these are pieces of data that you can use. We had 22 pre-admissions variables that we thought were important to look at. It turns out the vast majority of them did not successfully predict anything for us. They either had very low p-values or very low adjusted R-square values, and so we couldn't use them. This is something that you will have to do with your own data to figure out what works best and what does not work best. But identify as many variables as possible, and then you can at least be confident that you've looked at as many things as you could. Now for the MS1, so our first year in medical school, so what I just showed you was pre-matriculation, stuff they brought to them before they even started, and we only looked at 2 variables, and there are reasons that we picked these 2. We could have picked every single exam they had during the first year, and those are a lot of exams, but we chose not to for a variety of reasons. What we used is the percent exam score on the first institutionally developed multiple choice exam, and we used the overall percent exam scores for all of the exams, and there are quite a lot in the first year. So we used those as 2 different independent variables to look at step 1 performance. For MS2, we had a lot more variables that we ended up looking because, as you can imagine, the MS2 years were more clinical for us, and we had more opportunity to take these NBME, clinical diagnostics, subject exams, microbiology, pathology, pharmacology. These are higher yielding step 1, step 2 like exams that we decided to use as variables. So there were 13 variables that we looked at in a stepwise fashion. Okay, now let's actually go to our published results. And by the way, it just occurred to me that it's 2:35, 2:40, that I've been talking very, very quickly. So, and I'm realizing, okay, I'm wondering if everyone's following me. So, I guess is that when I'm done with all this, go and play back the presentation at half speed. But I apologize if I talk fast, so listen faster. No, I apologize if I am going too quickly. But I was just worried about getting everything done. Well, let's now look at our data, and I'll try to walk through this a little bit carefully. What you see is on the left side, we're looking at USMLE Step 1 prediction. And then on the top, you'll see academic milestones. So as you work through the data, we go from left to right. We go from the earliest milestones through, through the earliest milestones all the way to the latest milestones that would be available before Step 1 was taken. Once Step 1 is taken, you can't use that data anymore because the variables are gone for Step 1 prediction. So what you'll notice on the first column here, I'm not sure if you can see my mouse, you'll see an adjusted R-square value. That is the power, if you will. That is our best matriculation data came from only 2 variables. One of them was the undergraduate math and science GPA that they brought in with them, pre-matriculation-wise, and the lowest MCAT score. Those two have the strongest association, the best p-values, that made up an adjusted R-square of 12%. So these two things accounted for 12% of everything that could possibly go into the step 1 prediction. Now that's not very strong, but they are statistically significant. So again, this tells you that for us, pre-matriculation value, we would agree with the literature that suggests it's not so useful. But nevertheless, if you want to look at it, it's available. Then now you move over to MS1 and MS2 years. Now you start adding different exams, different variables, if you will, and in our case, exams. And what happens is some will drop out. So now this is 28%, almost 30% of the variance can be explained when we start looking at the first MS1 exam. This is what we call our end of the, EOM, Elements of Medicine exam. This is their first major exam they take, and it's a review of a lot of basic sciences. That actually correlates, in addition to their low MCAT score, which is one of the pre-matriculation values, to 28% of the variance. But you notice that the undergraduate math and science GPA has gone. And that's because when we did a multiple linear regression, this one turned out not to be important anymore. So that's the other take-home message, is that when you start to build and you do these stepwise linear regression, some of the predictors pop out and some will stay. Then we looked at all MS1 exams. So this is the first MS1 exam. This is at the end of the MS1 year, all of the exams together averaged out, and we got 2 data points. And by the way, these are all the coefficients. You don't have to worry about the numbers, but those would go in your formulas. This is the intercept, where it hits the excuse me, the y-axis. And again, these would go into your formula if you're choosing to look at current student data and predict using this data. 38%, now we've reached 38%, we start to look at MS1 exams. Now we look at MS2 exams, the first MS2 exam, plus some of the other variables. We get up to 46%. Now we look at all MS2 exams, we're up to 53% of the variance can be explained by these 3 variables. Not bad. And then you can see if you go all the way over to include some mini board exams and what we call our comprehensive basic science exam, which is very similar to step 1, so it makes sense. You could 3 variables can be used to explain 77% of the variance. So if you're going to bring this data to a student and say you're predicted, and you can actually use these numbers plus the intercept to predict their actual score, they're going to get a 193, which is only 1 point above passing if you use this data. That's very strong. That's 77%. The adjusted R-squared, 77% of the variance can be explained by these 3 exam scores that they have taken. And so that's a pretty strong correlation, and all are statistically significant. So I hope, I know this is a little rushed, but I hope you can understand that you're building these prediction variables into this formula that you can use to sit down with a student and actually tell them what their predicted value is. And you can do it with great confidence if your adjusted R-squares are good and if your coefficients are good. Now, here it is for step 2CK, and again, the exact data is not important because it's going to change in your institution. And by the way, this is all published, so you can actually look at this at your leisure, and I'll share with you the publication. But here is the early, so this is step 2CK, academic milestones, early, late, and this is the inclusion of step 1 now, so we use the step 1 exam as a variable for step 2CK, and then the final set of variables. And you can see, I'll just skip to this final set of variables, step 1 score plus a whole bunch of these mini boards actually were the strongest predictor out of everything we had. 62% of the variance could be explained by these 1, 2, 3, 4, 5 different exams that they take. So we can actually tell them with confidence 62% of variance explained if they give us, if we have their exam scores here, what their predicted step 2CK score will be. Okay, moving right along. I'm cognizant of time. It's 2:42, and I have a few more slides to show you. Most importantly, how we use this. This is a summary slide, kind of what I've shown you, so I'll skip that. But what do we do with this data? That's the exciting part. So at the end of each exam, the student data is automatically updated using the linear regression formulas and the variables that are most statistically sound. A database has been set up to capture the exam data for each student off of ExamSoft. So we have someone who's good at doing that. I'm not. Who's good at coding things and getting these the data to be imported at a certain way so that the statistical software can look at it the same for every exam or every student. Okay. The list of all students, and as you see down here, so then we have a list of all students and their predictions for step 1 or step 2, depending on what year they are, and that is made. So we have an academic dashboard. And students, here's the important part: students who are predicted to do well, there's no color associated. They remain unchanged. Students who are predicted to score around the exam pass-fail rate are highlighted in yellow. Students who are predicted to score significantly below the fail rate are highlighted in red. So these were non-at-risk students, medium risk, and high-risk students. Now let's take a look at what it actually looks like. We have an academic dashboard. Again, you have to log in, and only certain people can see this. And here's MS1 students. This is an MS1 example. We're looking again at risk in yellow and a red, pink, sort of at high risk. And we're using the most recent exams. And this is now the predicting variables that I've told you about. Pre-admissions, we've got the undergraduate GPA, and we've got the biology, chemistry, physics, and math, and we've got the lowest MCAT score. So we actually have their actual values for student X, Y, and Z, and then we have their predicted step 1 value of 219. Now, that probably doesn't mean much because it has a fairly low 12% adjusted ratio with a fairly high error. So we don't care so much about these values, but you could use these two pieces of information to predict how they're doing even before they get into your school. More importantly, though, is the AR squared to go up here to 38%. And in this case, it's predicting step 1 with the end of the year or the year-to-date MS1 exams. So what you show is here a student who actually got an 85% on their year-to-date MS1 scores is predicted to get a 222, and that's well above the passing rate of 192. This student, because they did less well, and because of all the other things they've done less well in, if you will, is got a 73 is on their year-to-date MS1 exams, is predicted to do 199, so only slightly above the pass score. So we might want to take a look at that student or talk to them or at least follow them carefully. And this student down here did a very, has a 56% on their MS1 year-to-date exams, and they're predicted to do below the pass rate. So we'll really want to make sure that we're following the student carefully and maybe even talking to them. We've done this for MS2, and as you can see, you get more, these things in blue here tell us we get more and more variables. Pre-admissions, MS1, MS2, with the variables I talked about. Here we've got 1, 2, 3, 4 students just in the screen capture that we would want to keep an eye on, and the other students are probably doing fine. I've covered their names, obviously, since we don't need to worry about that, but they would be visible to whoever wants to do this. And then we've got the MS3 example. Very hard to see, I know, but just to let you know, the important thing is you just get more and more data. Once you're an MS3 student, you've already taken step 1, so you're not predicting for step 1 anymore. Here in this case, you're predicting for step 2 CK. Now, it's still too early in the screen capture to have much, but what you can do is you can see your actual predicted values for the step 1 exam, because it's still on this screen capture. Even though you're looking at step 2 CK, you still have the step 1 data because the step 2 CK data uses step 1. And the point is that you can see the predicted step 1 and the actual step 1. And we're in the process of now validating all of this data, and we're actually finding that we're actually quite close. So our predictions are very close to what they're actually getting. And then, of course, we'll get more and more data, and it'll become more robust as more students in. And then here's the MS4 year. We've got pre-admissions variables, MS1, MS2, end of MS2, and MS3 years. And now we're starting to add more and more things, including the mini boards and what have you. And then you can actually predict, and you can start seeing what their step 2 CK predicted values are for student XYZ. It's at a 171 1, which is lower than the 209 cutoff. So we would want to really worry about that student. Okay? So, all right. I feel like that was a whirlwind of information, and I hope that it was clear to you. I think what is important for me to tell you is your data is going to change. The predicting variables that will become important for you are going to be very different, perhaps, than ours. Even what you want to predict for will be different. I mean, even your dependent variable, what it is that you're predicting, might be vastly different. The point is that I think, if I can say anything, is that we really should be using a data-driven process when we can, as long as the data is statistically sound and the formulas that you come up with are meaningful. So please do look at this in more detail at the Medical Science Educator. Thank you very much. I'll turn it over to you, Stephanie.
Wonderful. Thank you so much, Charles. What a wonderful presentation. We're going to go ahead and jump into the question and answer session of the program, everybody. If you do have questions, now is the time to type them into the questions area of the GoToWebinar control panel, which should be on the right hand of your screen. Charles, we had several questions have already come in, so I'm going to go ahead and jump right in if that's okay with you.
Yes, sure.
Wonderful. So first question is, have you compared your predictions after students take the CBSSA to the approximate step 1 equivalents that are provided in the individual score report?
Oh, okay. I don't. I know what you mean, and I have seen those reports. Well, first of all, we do not, none of this, it's a good question, and I can't answer it because I haven't looked at that data, and I don't take the CBSSA and compare it to those equivalent points per se. I let the instructors do that. I only get the data at the very end, and I'm really not, I'm not tasked to look at that, so I haven't looked at it. However, what I can tell you is that none of that goes into our predictive algorithm. I mean, in other words, we don't take the course, the NBME reports and do anything with them in our predictive algorithms, although it would be something that we could look to do. I hadn't thought about it. So I don't think I answered your question, and that's because I really don't know, because I don't do anything with those NBME reports per se. I'm really just concerned with the pass-fail score, if you will, the 192 for step 1 or the 209 for step 2 CK. So I apologize for not answering it directly, because I just don't really have a good feel for that.
Okay, next question. What has been the actual reception of students to being presented with more data-driven advice? Do they respond better?
Okay, and so again, I can only reply anecdotally, because our assistant dean of student affairs, she's the one who actually sits down and talks with the students with this data, or our dean will, but generally that's because they're really struggling and about to fail out or whatever. But now, so she has told us that most of the students are pretty good. They'd rather see the data. All students now know, because we have these communication channels now. We have these newsletters that I have started for closing the loop, and one of and we have told all of our students about this capability now, and we've let them know that it's available. And we've also let the students know that if you're struggling, we're going to find you, and we're going to be talking to you about this data. So they know about it. And our assistant dean has told us that a number of students have asked to see it, even though they're doing well. So I think that means, in general, they're quite receptive. But having said that, I know that she's a little bit reticent to show that data to every single student. It depends on how hyper or how damaging the student might take in hearing how they're going to do well. So she'll have the data in front of her. Whether she actually shows the actual number or not it depends on the student. But she certainly will tell the student, you're not predicted to do very well. And they'll often not be surprised, because they've not been doing well on their exams. But good question.
Okay, next question is, how often do you reset your linear model?
Yeah, that's a good question, because what we did is we took 5 years worth of data. As I mentioned, we developed a training set, and then we actually just started implementing this year. So we're taking students that are coming through. Even though I showed you MS3 and MS4 years, it's a little bit unfair because we double dip there. But my point is that we have not adjusted anything yet because we're only now starting to validate the actual and the predicted. Now we've seen that it's actually pretty close. There is a way to adjust it. I don't know. I'm gonna have to. That's something we're gonna have to do. There are these adjustment variables, adjustment processes to go through. So we haven't. I suspect that we'll need to do it once a year. And we're thinking about getting our next set of data together and publishing that very thing about how often we have to adjust it, what's the meaning, how important it is, and our actual versus predicted versus actual data, and how far off we were. So I don't know yet because it's still too new, but I'm assuming we'll want to do it at the end of every year, for example, and go back and come up with tweak our formulas, if you will. But there's probably some limitations in doing that. There might be. I'll have to look at the statistics language out there, and then folks who've done this. Maybe there are some guidelines that I should follow that you don't want to do it too often. I don't know, but good question. I wish I could answer it fully, but I don't know.
Okay, this is somewhat similar to the previous question that you answered, but I'm going to go ahead and pose it because it's phrased just a little differently.
Sure.
Why did you choose not to share the data with individual students? It would seem that it would be helpful to let them know where they stand with respect to a prediction for step 1.
Well, yes, and that's what my assumption was too. And I when we started doing this, I assumed every single student who was struggling. You don't necessarily have to show data to a non-struggling student, right? I mean, they're not. You don't bring them into your office necessarily. Now, ExamSoft, of course, has wonderful content-specific results that you can share, with your students for their exams that say, oh, your immunology scores are less higher or lower or whatever. But this predictive stuff, of course, we're really talking about struggling students. My assistant dean for student affairs, she's the one who said not all of the students will deal with this very well. So I guess the point is her concern is she may not show the actual numbers because it may, I'm going to use a colloquial term, freak them out. So in other words, we have some students who struggle academically. Maybe, I don't want to say cognitive difficulties, but they have some issues related to academic performance. Then we have a subset of students who are academically doing poor, but they have some underlying, what's the term? Psychological or, I wouldn't say physiological, psychological underpinnings. Maybe substance abuse, maybe depression. You have to be very careful. Those students may not accept the data the same way as a rational individual would. And the last thing you want to do is hurt the student. So that's why I don't know that our dean would automatically, our assistant dean for student affairs would automatically just go ahead and show every single student that was struggling their actual predicted results, because they may take it very poorly and it may hurt them. I don't know.
Okay, next question. Have you assessed the accuracy of the predicted outcomes post-hoc? Are there any legal ramifications or potential for complaints if the predictions prove to be inaccurate?
Oh my. So the first part of the question is, I think I've already addressed. We have not gone and done actual versus predicted, but we've done it in a soft test, like just looked at it, my colleagues and I, and seemed pretty good. But the second part of the question, legal ramifications. I hadn't thought about this. Now remember, these are predictions. They're predictions that can actually give you a number. In our case, it's step 1 and step 2. But, and there's an error associated with those predictions. So they'll give you a range. Now, I think because it's unlikely to be an issue of having an untoward legal issue, because I think the way we frame it, not the actual whether they get that whether they actually fail or pass per se, it's the way we approach it. I guess what I'm trying to say is that we're actually trying to help our struggling students. The point of predicting is not to give them the score. That's not necessarily because they may not get that score. The point is to say, look, this is what we want to do for you because you're predicted to do poorly. Now, if it turns out they do very well, I don't think that's a bad conversation to have, because if they're predicted to do poorly, they may need to study a little bit harder. And if they end up doing well, I don't think they're going to sue you or anything. However, I guess the opposite could be true. If they're predicted to do well and you've never discussed something with them and they do poorly, they end up doing miserably. The problem with that, of course, is that anyone at any time can do poorly. Doing well requires effort. Doing poorly requires something happening, like a grandmother who's very close to you passing away the day before your exam and you can't concentrate. So that, I guess if there would be some legal ramifications, it would be in that area, but I just don't see it. I hadn't thought about it. I mean, thank you for bringing it up. It's something that I can think about, and I don't know what limits of liability or legal issues exist out there for this kind of thing already, but it's food for thought. I just suspect it's not going to be an issue, but I could be wrong, I guess.
Okay, next question. Is your institution looking to use the pre-matriculation data differently at admissions based on this analysis?
Oh, I wish. You know, admissions committees can be very forward-thinking, data-driven, or they can be, I don't want to say backwards thinking, that's not the right way. They can have institutional policies in place that are rigid and have been that way forever, and that's why we do things. I suspect that our admissions, I'll be honest, our admissions committee is more the latter than the former. They know we have deans meetings where all the deans come together and we update our chief, if you will, once a month, and this predictive capabilities has come to their attention. I have offered, and they know, let me put it this way, they know that our pre-matriculation variables and the data that we use are not very strong. I don't know that they're going to do anything about it. I don't know that they can do anything about it. There's a lot of things changing anyway. MCAT scores have changed, I understand. So, so it's, boy, that's a tough question. No, they're not going to do anything with it now. If I plug away and really keep and convince them that we should be looking at this, and maybe the admissions committee should use data-driven processes, maybe I'll influence them. But just like anybody else, as you know, faculty, I work primarily with faculty. And I am a faculty. I teach immunology here. We're a stubborn bunch. If somebody tells us to start teaching using active learning, we're going to resist. So I think that's what I'm seeing at the admissions committee. The folks who run admissions, they're a little nervous to try something new or different. So not yet. The answer is not yet, but I hope so in the future.
Wonderful. Thank you so much, Charles. We are right up against 3 o'clock Eastern right now, so we're going to go ahead and wrap things up. Thank you so much for a fascinating presentation, Charles. This was really interesting.